Alright, today I want to run you through some quadratic formula practice. So if you take out your week 7 warm-up, we talk about on the week 7 warm-up, we talk about the zero product property, we talk about how you can approximate the solutions by using your calculator, using the analyzed graph, or looking through the tables if they're whole numbers. For number 1, I've got an example of that zero product property, where you just separate it and say, alright, if this times this equals 0, then this has to equal 0, or this has to equal 0. So our two solutions are negative 2/3 and negative 3. Those are our two solutions. Those are the two spots, those two x values where the graph crosses the x-axis. Alright. Now, in order to do the quadratic formula, you have to have the a, the b, and the c values. So in order to do that, you could use the box, or you can use the double distributive property here. 3n times n is 3n squared. 3n times 3 is 9n. 2 times n is 2n, and 2 times 3 is 6. So just combine like terms, we get 3n squared plus 11n plus 6. So in other words, we are saying that a equals 3, b equals 11, and c equals 6. So far what we've done is we've talked about the axis of symmetry. Remember, the axis of symmetry is the negative b over 2a. I'm going to write that right up here. Negative b over 2a. Alright? And then we've also talked about the discriminant. The discriminant, remember, is b squared minus 4ac. Alright? And then when we put those together with the plus and minus and the square root of the discriminant, it becomes the quadratic formula. This is the quadratic formula. So it can be broken down into the axis of symmetry and the discriminant. And basically what the quadratic formula is doing is it's finding the middle of the quadratic, it's finding the middle of the parabola, and it's saying the solutions are this far away from the left and to the right of that vertex. So that's why we add it and we subtract it. Remember, we talked about this yesterday. If this was 0, you only have one solution. If this is negative, you can't take the square root of a negative, so you would have no solutions. That's where it'd be above or below the x-axis, alright, and never cross it. So let's actually do the quadratic formula for this one. So I'm going to say x equals negative b, and b in this case is 11, so negative 11 plus or minus the square root of b squared, so 11 squared, minus 4 times a times c. Alright, I'm going to try to put everything in parentheses that I'm plugging in here. Right? So I plugged in the 11, I put the negative in front because it's always the opposite, and then that's all over 2 times a. Right? And we tried to give you enough room over here. I'm not quite sure if we'll have quite enough room. It might be a little bit crammed. But what we want to do now is we want to kind of simplify this. So what I would do is I'd take the discriminant and just plug it in my calculator exactly the way you see it. 11 squared minus 4 times 3 times 6. Just plug it in exactly like that. Alright? Then 4 times 3 is 12. And 12 times 6 is 72. And then we get 11 squared is 121 minus 72. So then we're left with, this is going to be the square root of, let's see here, 49. Okay. Now when you get a square root here where it is a perfect square, 49 is 7, square root of 49 is 7 times 7. Alright, when you get that, then you're good. You can go ahead and take the square root of that, and then you can split it and you're all set. When you get one where it's not a perfect one, you want to make sure that you leave it as a square root. So if that was a square root of like 47, we're going to leave that as a square root of 47 because we want to be as accurate as possible, and if we were to approximate that, it'd be a decimal that would go on forever.